Hi class, and welcome to Earth Science at John Logan College. This is an online class, so I wish that we could meet outdoors like I am right now, but that's up to you to explore the outdoors on your own. Hopefully this course will inspire you to do that and look under your feet to see what kind of rocks you might find. I'm just going to introduce myself a little bit and tell you a little bit about the class and some important information that will help you succeed and get a great grade in this online class. So first of all, my name is Laura O'Connell, and I love to explore the outdoors. That's how I got into geology in the first place. It's a great science to kind of put all the different sciences together in an interesting way. So that's how I got into it. I'm originally from North Carolina, and then I went to undergrad university at University of Miami in Florida and studied oceanography and marine science. And then I got really into geology. How can we look at ocean environments of the past and learn about them through the rocks? And so I got really interested in ancient coral reefs and things like that, and that's how I ended up in geology field. So after going to University of Miami, I ended up going for graduate school in Canada at Queen's University, and I studied some rocks and fossils and even the modern ocean today in Australia. So I got to go to Australia several times with my research. I've gone all over the world with research. It's a great field if you really want to travel and kind of explore the outdoor environment. Geology is for you. Anyway, back to my story. So I did my master's and PhD in Canada at Queen's University. I was studying how do we find out about ancient environments in the ocean. So what kind of fossils can we look for in the rocks that would tell us about the ancient environments and ancient climates of the ocean? And then if we're looking at the modern ocean, how can we determine information from what we're seeing today and what's on the bottom of the ocean today and compare that with the past and see how things have been changing throughout Earth's history? So that's what I was studying. So lots of scuba diving, lots of ocean boat work, snorkeling, lots of climbing around in the desert and exploring caves to look for rocks and things like that. So I'll also tell you a little bit about where we are right now, where I am outdoors. So in terms of looking for caves, this is an example. This is not a cave per se because it doesn't have a very dark area or anything in there. It's not completely covered with rock. But this is considered an alcove. So this is a feature that you find a lot in southern Illinois, and it's an erosional feature. So that's one place you could go and look for rocks. So I thought, well, what's the closest rocks to John Logan College where you can actually see an outcrop? So I drove down to Devil's Kitchen Lake. It's part of the Crab Orchard Wildlife Refuge. And I drove down here to go on a hike called Rocky Bluff Trail. So if you want to find a nice hike, it can be a long hike or short hike depending on which loop you do. This is a really good option. So right here, there's sometimes a waterfall. Usually there's a waterfall, but we've had a lot of really dry weather. And so usually the water runs down. And at the base of the waterfall, and also these layers you can see behind me, this is all sandstone. So this is a type of rock that is formed from sediment. And you've probably seen sand at the beach, at the lake, in a creek, things like that. So sand is just loose particles that have weathered off of rocks. So sandstone is just made of sand. So I picked up a few examples from the bottom of the waterfall. So you can see the tiny particles of sand in there. So this is the sandstone that the waterfall is made out of. But a lot of people think, well, okay, so we find sand in a creek. So this sandstone formed in this creek. This is actually a recent feature, this erosional feature. This alcove probably wasn't here at the time of the dinosaurs. This is a very recent thing. This is maybe in the past 100,000 years. That doesn't seem very recent, does it? But we'll find out the Earth is actually billions of years old. So this is a pretty recent event. I would think it's probably within the last 15,000 years, this alcove feature. And so this has been happening because of the river flowing through here. And, well, usually there's a river, a creek, and eroding the rock, and then pieces of it fall down there below the waterfall. You can see some of the pieces behind me right there. So that's a recent feature. But it takes a lot of pressure. It takes thousands of pounds of pressure to make a sandstone. Like this sandstone is a very hard rock. And these sand particles are stuck together with cement. So this sandstone rock, the rock we see behind us, this actually formed under probably 1,000 feet of sediment on top. So this formed deep underground, and then erosion has exposed this. So parts of the earth have pushed it up, and then erosional processes and water have eroded it down. So this actually probably formed a long time ago. And the sand that is part of this sandstone, a lot of people map, geological engineers and geologists map different areas. So this has been mapped as Pennsylvanian in age. So this sandstone I'm holding is actually from 315 million years ago. And the sand formed in a river. So similar to this environment, but actually not that similar. So there was these rivers, these huge rivers that came from the Appalachian Mountains. The Appalachian Mountains were forming at the time, 315 million years ago. And the Appalachian Mountains were huge. They were bigger than the Himalayas. They were the biggest mountains on Earth at the time. And that's a long time ago though, right? 315 million years. So those mountains have been eroding ever since. So that's why the Appalachians don't seem like very big mountains today. They've been under a lot of erosion since then. So at that time, huge mountains were forming. Appalachian Mountains, of course, that is out to the east. And there was these huge rivers coming down from those mountains and flowing towards our area. And so our area in southern Illinois was actually the edge of an ancient ocean at the time. There was sharks, there was coral reefs, there was sponges, there was jellyfish, fish, all kinds of cool stuff in the ocean here. But huge rivers were flowing in and dumping the sand. So just like if you went to the Mississippi Delta today, there'd be a lot of sediment. It'd be kind of murky water. You'd see a lot of mud, a lot of sand. You could go to the beach nearby and see the sand. So tons of sand was dumped by these rivers, and that made layers and layers and layers of the sandstone. And you've probably seen this on the side of the road, the sandstone. Not even thought about it. This is the color, kind of a brownish, tannish, grayish. Not very exciting to look at, but really cool story. So that was the delta that was dumping into the ocean in this area. I have seen estimates in the literature that there was 2 miles thick of sand in this area from the deltas. So very huge and interesting. So let me get back to the class really quick. I'll show you a little bit about what you need to get to prepare for this class. Hopefully you have an imagination and interest now. So also you need 2 books. Earth. This is actually a really cool book. It has some interesting features. This is the main textbook. So there'll be some assignments regarding the textbook. And if you open it up, oh look, sedimentary rocks. That's what we're just talking about. How awesome is that? There's some cool features in here. There's these little smart figure things with a tutorial, with a website and QR code. So if you're not a big reader and you don't want to read it all, or maybe you just want to do both, there's some videos associated with this that are really cool, interactive. They kind of show you how they put these figures together. Really cool little presentations. And then at the end of the chapter, there's also some that are kind of like podcasts where they ask questions and answer. And so that's kind of a nice way to study for the class. Additionally, there is this book. This is really important to get as well. This is the lab manual, Geoscience Laboratory by Tom Freeman. And the labs, I have written instructions that will be online for you as to what questions to answer, what parts to do, because there's a lot involved in these labs. But at the end of each of the lab manual chapters, so each of the labs, there's these answer pages. So this is what you're going to print out. This is for the MAPS lab. You'll print out a copy, or you can tear it out of your book if you want to, if you're not renting a book. And you'll do certain questions. So I'm only going to assign certain questions from the lab, so don't do the whole thing. And sometimes you'll be printing out a page like this and actually drawing on it as part of your assignment. So it's important to have the lab manual in a hard copy form. The digital form is really hard to use because you can't draw on a computer screen easily. So I recommend getting a hard copy like this, a paper copy. So I think that was all I was going to share today. This class is not self-paced, so there'll be assignments due every week. So keep an eye on that and don't hesitate to contact me. I am definitely here to help. I sure wish that we could meet out here, or maybe go on a trip to the Grand Canyon or a scuba diving adventure on the Great Barrier Reef, but we're going to make the most of our online experience and hopefully have a lot of fun. So if you're out and about, there is going to be an assignment regarding picking up a rock or a mineral and trying to figure out what you found and where you found it and all that. So if you find some cool rocks, go ahead and pick them up. Let's get going. Talk to you soon. Bye.